Welcome to the lab demonstration on the Layer 2 redundancy protocols of spanning tree and rapid spanning tree on Ruckus ICX switches. In this video, I'll demonstrate standard 802.1d spanning tree behaviors in a looped Layer 2 environment, how to configure 802.1w rapid spanning tree or RSTP, how to display information on RSTP port states and device roles, and show examples of failure scenarios and recovery times provided by rapid spanning tree. In this demonstration, I'll be working in the topology shown in the top right corner of the screen. We have three Ruckus ICX switches connected together as shown with static lags between switch 4 and switch 3 and a single link to switch 5. PCs are provided to show connectivity and the impact of connectivity when state changes occur in a spanning tree and a rapid spanning tree network. In this topology, all of the interfaces and VLANs are pre-configured. From left to right in the topology, we have a PC that's untagged on VLAN 222 on port 9 of switch 4. Switch 4 connects to switch 3 with two separate static link aggregation groups that are tagged on VLANs 222 and 333. Switch 3 connects to switch 5 with a single port that's tagged in VLANs 222 and 333 to switch 5, which has a connection to another PC that has two links. One link on port 9 that's untagged in VLAN 222, and one link on port 10 that's untagged in VLAN 333. This will be the topology we use to show the different spanning tree operations. Okay, so before we begin, let's take a look at our lags just to make sure they're properly configured before we start showing how spanning tree behaves. So we have our two lags, one with the name blue and an ID of 2, and one with the name green with an ID of 1. Each is a 2-port lag. They're up and they're forwarding on both ports. Okay, let's do the same on switch 4. On switch 4, we have both lags configured, up and forwarding. So we're in good shape here. Everything looks okay. We should go ahead and proceed. Now in this lab exercise, I will be frequently bringing up a PC, PC1 that's on the left of the topology, that is going to send pings to PC2, and we're going to use that to show the behavior spanning tree, things like recovery time and other scenarios when we have changes in the topology of the spanning tree network. So I'm going to bring up that PC right now. Okay, so from here, we'll do run ipconfig and look at our address. It's 10.10.200.100. We're going to be pinging the 10.10.200.200 address. So let's go ahead and start that now with the -T option to make sure that runs continuously. And we are good on the ping. So we have end-to-end connectivity between PC1 and PC2 through the topology that you can see here. Okay, so with that said, let's go back over to our switches, and we're going to take a look at which links we're seeing this traffic go over. We'll do this from switch 3. We'll run show statistics, and it looks like a majority of this traffic, let's see if I can get this centered for us, is using the 111 link in and out, because we're seeing a larger number of packets going in and out of that link. Port 11 is a link over to from switch 3 to switch 5, so of course that's going to be carrying traffic as well because we're going end to end between the PCs. And the other link aggregation group that is between switch 4 and switch 3 is seeing very little traffic over it. So that's so that tells us that the lag 1 group, or the port 1 lag, is a higher precedence than the other. So let's take a look and confirm that. So because these are recovery protocols and we have redundant links in here, we should be able to just go ahead and disable that active link, and hopefully we see a recovery on the other links. So let's go ahead and do that here. Let's get into switch 3 and we'll disable the primary port on that link aggregation group that connects over to switch 4. disable. Okay, so now let's look at our ping again. When we disable that link, we should see spanning tree kick in. Spanning tree is enabled by default on Ruckus ICX switches. So spanning tree should come into play and we should see these pings time out, but eventually we should see traffic restored. This will usually happen in about 6 pings or about 30 seconds because those are the timers that spanning tree uses to reassess the topology and determine that it's safe to start forwarding over alternative links again. And there we go. Our recovery time, we're back. Our recovery time is as expected at 30 seconds. And we can take a look at the interface statistics again and confirm that traffic is moving over the other ports. We'll have to run this a couple times just to confirm it and make sure that what we're seeing is accurate. So right now we're at 189 and 933 on this port. We'll run that command one more time. And those numbers have increased. So we are passing the traffic now over the second lag group on ports 21 and 22. Now let's re-enable that port and see what the recovery time takes on that one. So the port is re-enabled. Spanning tree should see this as a new link that comes up and reassess the topology because that's what spanning tree does. Once a new path comes up, it has to take a look at the entire topology again before deciding which links are going to be forwarding links. Once again, took us about 30 seconds or 3 pings that are either lost or a reply comes that says the host is unreachable. So this is basic spanning tree 8021D. When you have a change in the topology, you're going to see 30 seconds of downtime within that spanning tree topology network. So there's got to be a way to do this a little faster, and 8021W, or Rapid Spanning Tree, or RSTP, is a protocol that does that for us. It's an enhancement to the 8021D protocol that allows us to greatly decrease recovery time so that we can restore the topology to a normal state faster. So when we configure Rapid Spanning Tree on a Ruckus ICX, we configure it on a VLAN by VLAN basis. So we have 2 VLANs here in play, VLAN 222 and VLAN 333. So we'll get into each of those on switch 3, and we're going to enable Rapid Spanning Tree, and we're also going to configure a command that forces switch 3 to become the root bridge of our spanning tree topology. We do this so that we can have predictable behavior through the lab and determine, which links are going to change, which ports are going to go up, which ports are going to go down, and the behavior of our lab environment. So let's see, let's get into VLAN 222. And on this VLAN, we enable Rapid Spanning Tree or 802.1W Spanning Tree with the spanning-tree 802-1W command. So now we've enabled the protocol, and now we want to set the priority to ensure that this switch becomes the root bridge. So I'm going to set it to 4096. The default priority for a spanning tree bridge is 32768 on a Ruckus, so this will definitely put us low enough to become the root. All right, let's do the same for VLAN 333. I'm just going to use the up arrow to save us some time here. Okay, now both VLANs are configured with 802.1W and the priority of 4096, which should ensure that switch 3 becomes the root. Now we'll come over here to switch 4 next and perform the same configurations, although we won't set a priority here. We're only going to configure 802.1W on the 2 VLANs. And for this, we can just shorthand the command. So instead of spanning dash tree 802-1W, we can just type span 8 and enables them on the VLAN and enabled on the VLAN. So now we have 802.1W rapid spanning tree configured on VLANs 222 and 333 on the switch 3 and switch 4. So let's take a look at what that did for us. So we're going to run the show 802-1W command on VLAN 222, and we'll take a look at what we get here. So we are looking at switch 4. So on VLAN 222, it identifies itself as this bridge ID ending in CC00. It identifies the root bridge ending in C660. So this is not the root bridge. The root bridge that it's seen and accepted as the root is seen on port 111. Port 111 is a link aggregation group connecting over to switch 3, which we expect to be the root because we explicitly configured it to have a lower priority than the priority configured on this switch. These 4 hex characters describe the priority that's configured. So 8,000 in decimal is 327068, and 1,000 in decimal is 4,096. So let's take a look at our ports down here. Our root ports confirmed are 1/1/1 and 1/1/2 because they're a link aggregation group. And we have alternate ports on 21 and 22. These are alternates because they also reach the root bridge, but they're less favorable than the other ports at the same cost. So we look like we're running a good spanning tree network here. Let's take a look at our pings. They're still continuously moving. I like to stop the ping and run it again because the screen doesn't look like it's actually still sending them or look like it could even be locked up. So I just like to verify. Okay, so now let's say I would like to change the root port. So from the root bridge, I want to instruct downstream switches that I want them to use a different root port for VLAN 222, but not for 333. So let's see how we can do that. So we're going to do this from the root. So the root is switch 3 over here. So we'll move over to VLAN 222. And in VLAN 222, we'll set the 802.1W spanning tree port priority for Ethernet port 1/1/21. And we'll set that priority to 16. 16 is a nice low value. The default is 128. You can set this values in increments of 16, and the lower priority, the more preferred that link is. So we'll set that for VLAN 222, and then we'll jump back over to switch 4 and see what that impact is. So we can run the show 802.1W on VLAN 222 again. And when we get to these ports, you'll see now that port 1 and 2 are alternate ports, and port 21 and 22 are the root. Now let's run the same command for VLAN 333. And here we see it's performing the same as 222 was earlier, with ports 1 and 2 as the root ports, and 21 and 22 as alternate. Now I said earlier that rapid spanning tree is more preferred than regular 802.1D spanning tree because it recovers faster. Well, let's take a look and confirm that. Let's go over to switch 3. We'll jump in here and we'll get into interface 1/1/21. Now I'm doing this on 21 because 1/1/21 is now the root port from 4 to 3, right? And it's that way because we changed the port priority to 16 on the switch. So it's more preferred on VLAN 222. Now the pings we're running from the PCs are on untagged ports in VLAN 222. So I'm doing this on these ports specifically so that I can see the impact of what it does to those pings that are running between the two PCs that are on VLAN 222. So I'm going to disable the root ports. I only have to do it on port 1121 because it's the designated port for the link aggregation group, and anything I do to this port will be applied to port 22 as well. So that port is disabled, and we'll take a look at our ping. So when that port goes down, we see one ping drop and connectivity is immediately restored. So in rapid spanning tree, when there's an outage of your forwarding path and there's an alternate port available, that alternate port can be brought up very quickly and connectivity is restored very, very fast. Now, when we enable a port with rapid spanning tree, we do have to reassess the topology again. And to reassess the topology, we have to go through some of the normal spanning tree processes, unfortunately. So we can jump back in to switch 3 and re-enable this interface. And then we'll look at our pings and see what the impact is. So the port's been re-enabled. The topology has to reassess itself. The switches have to rediscover what are the better ports, which are the root ports, and how it's going to behave. So what we're going to probably see here is we should see about 6 pings, 30 seconds of downtime to recover from a new link being placed in the topology, especially a link that is actually going to come up and be the preferred link over the rest of the links there. So here we go, connectivity is restored, and we're back in business. So some of the ways we can continue to speed up rapid spanning trees transitions is by statically defining what types of ports things are. So we can define ports as switch-to-switch connections or point-to-point connections that are between switches so that each switch in the topology can know or expect to know that the device on the other end of that is another rapid spanning tree device. Let's go ahead and enable some point-to-point links in our topology here. So we'll start on switch 4. And I am just going to paste this in because my typing is not the best here. So we're going to set on VLAN 222 port 1, and by virtue of it being a primary port, it'll also set port 2 as an admin point-to-point interface. So these are defined as switch-to-switch links. So we'll do that as well to port 21. And we'll do the same for VLAN 333. And we'll go ahead and do this on switch 3 as well. Port 1, port 21. So now these ports are admin point-to-point ports. So we can see that in the show 8 or show 802-1W output. And when we look at these ports, they are defined as point-to-point MAC ports. You can see that right here. They are true, and it is false on the port 11 port. We could have configured it for the connection over to switch 5, but you saw in the example there, we only performed that configuration between switch 3 and 4. Okay, so now that we have defined these ports as point-to-point ports, let's go through and run through our scenario again of disabling that interface and re-enabling it and seeing what our response time is. So we'll get into port 21. 21 is the forwarding port for VLAN 222, which is the one our PCs are on. We'll disable it and take a look at our ping window. So we see 1 and we recover and we're back in business. So let's jump back over here and enable the port and take a look at our ping window again. And we don't see any transition at all. So this is exactly the behavior we should expect from rapid spanning tree. By defining interfaces as point-to-point interfaces, it allows us to really cut down the downtime on recovery of a link completely and still keep a very tight limit on the downtime that's impacted to anyone when we lose a link that's the primary port or the port being used to carry traffic. And if you think about it, that one ping that's lost was probably literally on the wire at the point that that was dropped. So nothing's really going to notice that there was an event here at all, which is much faster than what we saw with the regular 802.1d spanning tree, where either a loss of a link or the regaining of a link always led to a 30-second outage of connectivity between devices. So this shows the spanning tree operations and the rapid spanning tree operations on the Ruckus ICX switches. I hope this was able to help you understand how to configure some of the features related to rapid spanning tree and the benefits of rapid spanning tree, and why in most networking environments you're definitely going to want to consider transitioning to rapid spanning tree over the default 802.1d spanning tree. The default is configured and active by default, and that's really for your protection, to just ensure that if there are any loops in your network when you're connecting these devices together, that the ports won't result in an outage on your network by creating a loop.